Hello everyone, welcome to this presentation. Today I'm going to talk about one software for data acquisition, CART. In this slide, in this presentation, I want to talk about data acquisition software. I'll talk about software for monitoring and test, how we can test a digital input and how we can test digital output, and how we can measure and test and monitor analog input, and how we can test and monitor and measure analog output. First step, to work and configure data acquisition in the software, we need to install one software. This software, name of this software is DAQ Navi, DAQ Navi. You can download it from this website, Advantech website, and then when you download the software from this website, you can install the DAQ Navi offline software, and you can press the continue to install DAQ Navi offline software in your PC or your laptop. After you install the DAQ Navi software, you can see this page. In this page, there are 5 items you can select. The first item is test this device. You can click on go and you can see this page. In this page, you can see there are 4 tabs. The first tab is about analog input. Second tab is about analog output. Third tab is about digital input and output if you want to configure. And the last tab is about counter input and output. So now in this slide, I want to explain how we can configure analog input. If you click on analog input tab, you can see some option. You should configure that. The first item is channel selection. You need to select which channel you want to work. For example, in this slide, you can see AI0 or channel 1 you want to work or you want to measure by channel 1 or AI0. Another one is what type of input you want to work. For example, you want to work with differential type signal, or you want to work single-ended type. But two different format of signal, you need to select which one you want to work. At the moment, I selected for single-ended type signal I want to measure. In this slide, you can see range of limitation. What is the level of voltage I want to measure? For example, in this slide, you can see from -10 until 10, I want to measure or I want to measure sensor signal between -10 until 10. So the range, as a result, I can say that the first item is channel selection. Second item is what type of sensor you want to work, and the third option is what is the range of limitation or what is the range of measuring sensor you want to do. For example, sometimes you can select 0 until 5, sometimes you can select 0 until 10, sometimes you can select 0 until 2.5, and sometimes you can select -10 until to 10, or sometimes you can select -5 to 5. After configure this item and choose the best option for your measuring, you can click on the start, and start. When you click the start, measuring and monitoring the signal is done, and analog input 0 is measuring the sensor signal and can show it will be shown in the window, and you can see the signal in the window. Here there is an example to measure analog input. Analog input is produced by potentiometer, and the middle pin of potentiometer is connected to AI0 pinout number 2, and in the right hand side you can see a picture that is measuring the signal. Signal is from 1.45 to 5 volt as an analog input. When you change the potentiometer, you will have a variation in the voltage and analog input voltage. The voltage will be between 0 until 5. As you can see in the right hand side picture, the voltage change is from 1.45 to 5 volt. Also, the minimum range of the voltage will be 0 until 5. In this slide, I want to configure analog input and measure the voltage and produce the voltage from analog output, and to send it to analog actuator. In the tab section, tab number 2, you can see analog output tab, and you can select the channel of analog output, and here you can configure the range of limitation for analog output voltage. For example, you can fix that from 0 to 5, or 0 to 2.5, or 0 to 3 volt, and something like that. And you can change the analog output voltage from 0 until 5 by this type of a slider, and you can send the command and voltage to analog actuator, and by this approach you can send the command and analog output voltage to analog actuator, and can change the analog actuator and can send the command to analog actuator. So in this slide, 2 point is very important: channel selection. What type, which channel do you want to send the command, and what is your voltage limitation and voltage range. Now I want to explain how we can use the digital input and output. The first point we need to consider about that is port selection. Which port do you want to work? For example, port number 0 or port number 1. After in this slide, we configure port number 0 to use, and in the right hand side you can see some display and digital input indicator and digital input selection. Digital input selection, it means that which digital input do you want to work, or do you want to select and send a command. And in the below you can see some indicator. For example, indicator number 0 depends on to input number 0, indicate number 7, it depends to digital input number 7. And this point here, I can say that this type of digital input is based on an active low. So the indicator is always on when the key or when the signal is 0, the LED will be turned off, and it shows that the input is activated. So this type of input, or 8 input, they are active low, and you can see the action in the following indicator from 0 to 7. So the final point is that this type of digital input is active low. So the first, as a default, LED is green or turn on, and when the signal is off or digital signal is off, you can see the reaction for the indicator or input is activated. Now I want to explain about digital output tab and digital output section. You can see here all output from 0 to 7. We have 8 output. You can see the reaction in each signal point. For example, if the output is 0, the signal 0 will be 0. If the signal is 1, the indicator can show us the signal output is on. So in the all output tabs, you can see all output from 0 to 7. We have 8 output. You can send the command from data acquisition to digital output or physical environment. In this slide, you can see how we can send the command from DAQ Navi to digital output. Top bottom, you can see all output from 0 to 7. We have 8 output. The bottom tab, you can see we can send the command 0 signal or 1 signal by choosing the key in the 0 side or 1 side. For example, in pin 0, you send in pin 0, in tab 0, you are sending a 0 command to digital output. In the 7 pinout or tab, you can choose the another level. For example, you can choose the high level and send a high level voltage or 5-volt voltage to digital output. So there are in this picture you can see 2 tab. One tab, the number of digital output 0 to 7, and the bottom tab you can see what type of signal do you want to choose. For example, 0 or 1. Each one, do you choose 0 or 1, you can send the command for each channel from digital output. If you want to have an extra digital input and output, you can see that in port number 1. As you remember that port number 0, we had 0 to 7 digital input or output. So we have 8 input or output. If you want to have an extra digital input or output, you can select the port number 1, and we have 4 input or output in this port, and we can use for as a digital input or as a digital output. In this slide, I want to explain about how we can connect a level sensor to data acquisition and how we can measure it in DAQ Navi software. As you can see here, we connect the data acquisition module we connect level sensor module to data acquisition card, but the signal is light blue is connected to P0.0 port 0 bit number 0. So as you can see in the right hand side, you can see the DAQ Navi software window, and the sensor 0 is turned off because this sensor is active low, and this at the moment sensor is on, and the indicator is turned off. And as you remember in the previous slide, we told before this type of a digital input is based on an active low. When the sensor is low, the indicator is turned on, and another indicator from 1 to 7, all of the indicator is turned off. Thank you for your attention. See you on next lecture. Thank you.